Welcome to Matan Malapur's channel. Today, we're diving into one of the most exciting developments in energy science, recent breakthroughs in nuclear fusion. Could we be on the brink of unlimited clean energy? Let's explore this groundbreaking technology and its potential to revolutionize our world. Nuclear fusion has long been considered the holy grail of energy production. It's the same process that powers our sun and other stars, where atomic nuclei combine to release enormous amounts of energy. Unlike nuclear fission, which splits atoms and produces radioactive waste, fusion promises clean, safe, and virtually limitless energy. The challenge has always been recreating the intense conditions necessary for fusion here on Earth. Stars achieve fusion under immense gravitational pressure and temperatures. Replicating these conditions has been a monumental scientific and engineering challenge, until now. In December 2022, scientists at the National Ignition Facility at Lawrence Livermore National Laboratory in California achieved a historic milestone. For the first time in human history, they produced a fusion reaction that generated more energy than was put into it. This achievement, known as net energy gain or ignition, has been the goal of fusion researchers for over 60 years. The experiment used 192 high-powered lasers focused on a tiny fuel pellet, creating temperatures and pressures similar to those at the center of the Sun. The pellet, a mixture of deuterium and tritium, both isotopes of hydrogen, fused together, releasing more energy than was input by the lasers. While this breakthrough is monumental, it's important to note that we're still a long way from fusion power plants. The experiment produced only about 3.15 megajoules of energy, enough to boil a few kettles of water. However, it proves that ignition is possible, opening the door to further advancements. Several other approaches to fusion are also showing promise. The ITER project in France, a collaborative effort involving 35 nations, is constructing the world's largest tokamak, a magnetic confinement device. Expected to begin operations in 2025, ITER aims to be the first fusion device to produce net energy over an extended period. Private companies are also making significant strides. Commonwealth Fusion Systems, a spin-off from MIT, is developing high-temperature superconducting magnets that could enable smaller, more efficient fusion reactors. Meanwhile, UK-based Tokamak Energy has achieved plasma temperatures of over 15 million degrees Celsius in its spherical tokamak devices. The potential benefits of fusion energy are enormous. Unlike fossil fuels, fusion doesn't produce greenhouse gases or long-lived radioactive waste. The fuel, primarily deuterium, can be extracted from seawater, making it virtually inexhaustible. A fusion power plant would produce no air pollution and would be inherently safe, with no risk of meltdown. If successfully developed, fusion could provide baseload power to complement intermittent renewable sources like wind and solar. It could power desalination plants to provide fresh water, enable large-scale carbon capture to reverse climate change, and even power interplanetary spacecraft. However, significant challenges remain. We need to scale up the technology, improve efficiency, and develop materials that can withstand the intense conditions inside a fusion reactor. The economics of fusion power plants also need to be worked out to ensure they can compete with other energy sources. Despite these challenges, the recent breakthroughs have injected new optimism into the field. Governments and private investors are pouring billions into fusion research, accelerating progress. The UK government has announced plans to build a fusion power plant by 2040, and several private companies aim to have demonstration plants operating in the 2030s. Critics argue that fusion is perpetually 30 years away, but supporters counter that the timeline is shortening. The recent breakthrough at Livermore has shifted the question from "can fusion work?" to "how soon can we make it practical?" As we stand on this precipice of a potential energy revolution, it's worth considering the words of Arthur C. Clarke: "Any sufficiently advanced technology is indistinguishable from magic." Fusion power, with its promise of limitless clean energy, may seem like magic, but it's the result of decades of scientific perseverance and ingenuity. The journey to practical fusion power will require continued international collaboration, substantial investment, and innovative problem-solving. But the potential rewards, addressing climate change, providing abundant energy for all of humanity, and opening up new frontiers in space exploration, make it a challenge worth pursuing. In conclusion, while we're not quite there yet, recent breakthroughs suggest that we are indeed on the brink of a new era in energy production. The dream of harnessing the power of the stars here on Earth is closer to reality than ever before. As we continue to push the boundaries of science and technology, fusion energy stands as a beacon of hope for a cleaner, more sustainable future. Thank you for joining me on this exploration of the exciting world of nuclear fusion. If you found this video informative, please like, subscribe, and hit the notification bell to stay updated on the latest developments in science and technology. This is Matan Malapur, reminding you that the future of energy might be closer than we think. Until next time, keep exploring, keep questioning, and keep believing in the power of human ingenuity.